we are going to find the wavelength of laser using Michelson interferometer. So this is our aim. We are going to find the wavelength of laser. So what is laser? Light amplification stimulated by emission of radiation. This is laser. So we know the characteristics or special characteristics of laser. Laser is highly monochromatic. Laser is highly coherent. It has high intensity, etc. All these things we studied in theory. Okay. Now we are going to find the finite or definite wavelength of laser. Okay, what are the apparatus required? Light source, Michelson interferometer kit, optical bench, meter scale. So we know the theory, the basic things is when the two light waves having the same wavelength and amplitude travel through same medium, their amplitude combine. Okay, so sometimes the amplitudes may add. Okay, the addition of amplitude due to superposition of two waves is called interference. Superposition of two waves normally gives interference. So when a crest of one wave and trough of other wave add together, the resultant intensity is zero. That is called destructive interference. So we studied in theory. So another case is when crest of one wave meets the crest of other wave, the resultant intensity is maximum. This interference is called constructive interference. Okay. Okay, with these basic things, we are going to calculate the wavelength of laser. Okay, with this concept, we know the formula for calculating. So, as per the theory, what we have obtained, the formula is wavelength of laser lambda equal to 2d divided by capital N. Okay. This is the formula. Using this formula, we are going to calculate wavelength. Okay. So before starting the experiment, once we go through the procedure. Okay. Go to procedure. Procedure is the laser beam must strike at the center of movable mirror, should be reflected directly back into laser aperture. Okay. Adjust the position of beam splitter so that beam is reflected to fixed mirror. Initially we are adjusting the position of beam splitter. So the we should adjust the position of beam splitter up to 45 degree. Then only there will be two set of bright spots on the screen. One set will receive from fixed mirror, other set receive from movable mirror. Now adjust the angle of beam splitter to make two set of spot as close together as possible. With the screws of back of adjustable mirror, adjust the mirror's tilt until two set of spots on the screen coincide. Now expand the laser beam slowly by rotating the collimator lens in front of laser. Now align the laser with the interferometer and make center that the fringes are moving when the micrometer screw is turned. Mark a point on the screen, note the micrometer reading. As the screw is moved, the fringes begin to display. It may display towards inward or outward. Now we need to count the number of fringes that move either inward or outward. Okay. Now we should note the beginning and end of the micrometer reading. So with this reading, we can calculate the wavelength of laser using this formula. Okay. So now directly we go to simulator. By using simulation, how we are doing this experiment. Okay. Now we are going to move into simulator. How we are doing this experiment. In the simulator, first we need to select the laser source. So the laser source is krypton available, helium neon available. Okay, this is the simulator. See, this is the simulator. Here, first we should choose available laser, any one, krypton or helium neon or argon, any laser. It's our choice. Now switch on the power. So this is laser source. No, this is source. This is beam splitter. This one is screen. This is micrometer. Okay, now we switch on laser source. As a result, we are getting some spot on the screen. Now we are adjusting mirror. We are adjusting mirror. We are adjusting mirror up to we are getting bright spot. Now we get bright spot. Now we get bright spot. Okay, now we are going to adjust the micrometer reading. So initially using mouse, drag this micrometer reading and keep some value here. Okay, right. So this is the initial micrometer reading. Next, what we are doing, so we are rotating or we are adjusting micrometer, and here in the screen we are counting how many number of fringes are moving, either inward or outward. Okay, now we should fix one point in the screen. At that point we are counting how many number of fringes are moving. Now I am rotating micrometer, so the initial micrometer reading is noted. Now I am rotating for 10 fringes, up to 10 fringes. So this is one fringe, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, 10. Okay, now we moved 10 fringes. Now we move 10 fringes. So now the final micrometer reading also noted. Now we move 10 fringes. So final micrometer reading also noted. So this difference in the micrometer reading gives the distance moved D. Okay. Now if you select show result, automatically the parameter is substituted in the above discussed equation, and finally wavelength of laser source is obtained. Its wavelength is 488 nanometer. Okay, so this Ri means this refractive index of glass. It is not necessary for us. So now you can repeat the experiment. How do you repeat the experiment? So now you can reset the if you press reset button, the entire now the instrument go to the initial position. Okay, again you can repeat the experiment. You can repeat the experiment by changing different laser source, or by keeping glass plate, or you can change the thickness of glass plate. So multiple times you can repeat and do the experiments. Okay, so in physics laboratory, manually we are measuring the distance. Here automatically the simulator calculating the distance moved. Finally we are getting wavelength of laser. So this is wavelength of laser source by using interferometer, Michelson interferometer.